Moving on to F and G. So F, we note that there is a 1 and a 0, just not in the right position. And then we're going to have to get another 0 and a 1 somehow. So let's go ahead and begin with what you weren't thinking about. You probably wanted to go ahead and maybe switch. Let's not do that yet. Let's just go ahead and see where this takes us. Let's take half of row 1. So let's begin simplifying things a bit for us. If we take half of row 1, it's going to make half of 2 is 1, half of 4 is 2, half of 10 is 5. We will switch row 1 with row 2, so you can start getting those things in place. Remember, folks, we're doing addition and multiplication. That's all we've been doing for the last four weeks. No variables, no exponents. It's been nice, I hope. Now, we have a 1 and a 0 already. Let's get this to become a 0. So I need these two numbers to be opposites of each other. They're the same value. They just need to have different signs. So let's go ahead and get one of these to be negative. Right, we're going to do row 1 and we're going to do row 2. But the question is, which one of these do we want to be negative? First of all, we're going to deal with both rows. And second of all, whatever we get, we're going to put it back in row 2 because what I'm going to get is a 0 and I want it to go back into row 2. But the question becomes, okay, which one do I want to become negative? Well, if we think ahead, less negatives are better. So if I go ahead and make row 1 negative, I get negative 1 times 0, which is 0. I don't have to worry about a negative. If I do a negative 1 to row 2, I end up picking up extra negatives that will create more work for us to do. And I know we're not about more work. At least I'm not. So let's go ahead and look at row 1. Negative 1, row 1 would be negative 1, 0, negative 1. Row 2 would be 1, 2, 5. If I go ahead and add those up and down, I get a 0, a 2, and a 4. And now this becomes my new row 2. And here it is. Now at this point, would you please note we have the 1 in place, a 0 in place, a 0 in place, and I need this to become a 1. I trust you at this point. I trust you. You've gotten this far. So you know what this next step is. You know what the final step is. You know. And if you do that, you're going to get 1, 0, 1, 0, 1, 2. And I'm not going to fully explain that because at this point you should know, and I trust you. G. Well, G has no zeros, but it has a lot of ones. You know, this and this, these elements are both the same value, but they're opposite signs. So if we were just to add them up at this point, we would get a 0 somewhere. So let's go ahead and try that out. Let's just simply add them and put it back in row 1. Okay, and when we add this, we're expecting to get a 0, right? So when we do these kinds of problems, note, like we're always focusing just on one number, but everybody else comes along for the ride, and everybody else is affected because of that one number. Okay, so we have our row 1, we have our row 2, we add them up and down. That is my new row 1. This row 2 comes along for the ride. Let's go ahead and pick up another 1. So let's take care of this right now with a 1/2 row 1 back into row 1. That means I'm going to take half of everything in row 1. Half of everything in row 1. So what's half of 0? 0. Half of 2? 1. Half of 2? 1. And of course this row 2 I didn't change, so that comes along for the ride. Let's go ahead and switch rows. So we'll switch row 1 with row 2. Start making this look as it should. We have our 1 in place, our 0 in place, our 1 in place. This needs to become a 0. At this point, if you don't know what to do, you got to go back and rewatch the last video because this is pivotal. I'm going to go ahead and add these, but I'm going to do the opposite of row 2. And whatever I get, I'm going to put into row 1 because I need this squared term to be 0. Okay, this got to be a 0. So here's my row 1, here's my row 2 the way it is right now. I'm going to multiply everything in row 2 by a negative, so that means I switch all of these signs to the opposite signs. I add them up and down as a 1, a 0, and a 0. Interesting. That is my new row 1. And this is our answer as expressed in reduced row echelon form. What does it all mean? Remember in Algebra 1 this system of equations and how they taught you in Algebra 1 to solve it one of 3 different ways: elimination, substitution, or graphing, everyone's favorite. Well, we propose to you that what we've been doing with reduced row echelon form is another method for solving systems of linear equations from Algebra 1. So technically we've been doing Algebra 1 all this time, even though it looks really difficult. If you recall from our first lecture note, in our first lecture video on Introduction to Matrices, we did an exercise where I told you to express things like this, right, a system of equations in form of a matrix. So if I were to express this system of linear equations in the form of a matrix, the coefficients go in the elements for each of this matrix. So I have a 1 in here, a -5 in here, and a 4 in here. So everything in Algebra 1 that you did with elimination, substitution, or graphing could have been expressed as a matrix. You didn't have to worry about x's and y's anymore. You could have just worried about the numbers themselves, the coefficients, and then taking this 2 by 3 matrix, express it in reduced row echelon form, and you would have gotten the same answer as you did in Algebra 1. In summary, I want you to try the above problems, right, A through G, again on your own. See how you do. Try not to look at the notes, and then compare to see how you did and areas that you can improve in. Then I want you to try these out.